In today's lesson, we're going to be looking at 1.6 combining exponent laws. Let's start with our learning targets. At the end of today's lesson, you should be able to use exponent laws to simplify expressions, and you'll also be able to solve problems involving powers or radicals. Now, the focus of today's lesson is going to be on simplifying those expressions, and these expressions are going to be quite a bit more challenging than the ones that you saw in topic 1.5. All right, so before we get into the examples, let's just do a quick refresher on our basic exponent rules. So the first is our product rule. If I have the product of two powers with the same base, I can add my exponents. The quotient rule says that if I'm dividing two powers with the same base, I can subtract my exponents. And the power rule says that if I'm raising a power to another power, I can multiply my exponents. The other three rules here are just extensions of those. So if I have a to the m times b to the n raised to the power of p, I can distribute that p through. So that becomes a to the mp times b to the np. And if I'm taking the quotient of two powers that have different bases, that p can also be distributed. So a to the mp divided by b to the np. And then I have that special case, anything to the exponent of 0 is 1. Because if you remember, if I have a to the fourth divided by a to the fourth, that's the same as a to the 4 minus 4, which is a to the 0. And since a to the fourth divided by a to the fourth is 1, a to the 0 is also 1. So let's take a look at some examples. Here I have negative 7a to the fifth times 6a to the 12. What we're going to do is we're going to multiply our coefficients, and then we're going to combine our powers. So negative 7 times 6 is negative 42. And a to the fifth times a to the 12, these are powers with the same base, so I can add my exponents. 5 plus 12 is 17. 30 divided by 45. Well, I can reduce that. So if we think about this as a fraction, I've got 30 over 45. If I divide both of these by 15, that's going to leave me with 2 over 3. If you struggle with reducing fractions, you can use your calculator to help you. We can go 30 divided by 45, and then math, choose 1 for fraction, math frac, and then it's going to convert it to 2 over 3 for you. So that gives us 2 over 3, and then we have x to the 14 over x to the 10. 14 minus 10 is 4. So we can write this as 2/3 times x to the fourth, or we can write it as 2x to the fourth divided by 3. Now for our final example, we have that negative there. And so what I'm going to do is I'm going to move that negative up with the 2. Really, it can move to the top or the bottom. I'm going to put it with the 2. So I've got negative 2 times a divided by y cubed. And that all is bracketed and put to the exponent of 3. Now that 3 is going to distribute to each of these. And if you remember, negative 2 is like negative 2 to the 1. So now we're going to have negative 2 to the exponent of 3, a cubed, and on the bottom, 3 times 3 is 9, so we're going to have y to the 9th. So negative 2 cubed can be evaluated. That's going to give me negative 8, and we're going to have negative 8 a cubed divided by y to the 9th. Now in example 2, we have some examples that are a little more complex, some that are still the basic rules, and we're just going to talk through them. So I have negative 3 a squared times b cubed, all put to the exponent of 2. Once again, that 2 is going to distribute through, but brackets are really important, especially when I'm working with even exponents. So this is negative 3 squared. It's important to note that negative 3 squared is different than negative 3 in brackets squared, because if there's no brackets, that means the 2 only applies to the 3. So that would be like negative 1 times 3 squared, which is negative 1 times 9, which is going to give me negative 9. If I have negative 3 squared, that means negative 3 times negative 3, which is a positive 9. Now we can also verify that with our calculator. If I type in negative 3 squared without the brackets, I'm going to get negative 9. If I put negative 3 in brackets squared, I'm going to get 9. So it is quite common that we do make these silly mistakes. We forget those brackets when we're putting it into our calculator, and that negative changes our answer. So just being aware of that. Again, if it's an odd exponent, that's not going to be an issue, because if I multiply a negative times a negative times a negative, I'm still going to get a negative. So missing those brackets with an odd one isn't a big deal, but it is with an even. So I just use brackets all the time. All right, so going back to our example, we've got negative 3 squared, and then a to the fourth, and b to the sixth. Negative 3 squared, we've already figured out, is 9. So we're going to have 9 a to the fourth, b to the sixth. Now the question might come up, how do I check my work? How do I know that I'm right? We can do that with our calculator. So with our calculator, we can check by using substitution. So you're going to arbitrarily assign a value to A and to B. So let's say that A is going to be 2 and B is going to be 3. So on your calculator, you can go -3 times 2 squared times 3 cubed, close your brackets, and then we're going to square it. And that's going to give me 104,976. Now I'm going to check my answer, my simplified answer, and I'm going to have 9 times 2 to the 4th times 3 to the 6th. And if I've simplified correctly, I should have the same answer, and I do. Now I can actually use my calculator to store these values as well. So I can tell the calculator that 2 is going to be stored as alpha A, and 3 is going to be stored as alpha B. So now instead of typing in those numbers, I'm just going to type in my letters. So my first expression here says -3a squared b cubed and then all squared. So I'm going to have -3 times alpha a squared times alpha b cubed and then all squared. And that should give me the same answer as my simplified expression. So then 9 and alpha a to the exponent 4 times alpha b to the exponent 6. And again, I have the same answer. So you can use that method of just storing your values as well. Numbers that I try to stay away from, I don't usually use ones or zeros for substituting just because they have some special properties that might cause me to think my answer is correct when it's actually not correct. So typically I'll stick with 2s, 3s, and 4s as my substitution numbers. All right, so here I have -m to the 6th divided by -m to the 4th. So my base is -m, so that's going to stay in brackets. 6 minus 4 is 2. Notice that's an even exponent, so those brackets are going to make a difference. This is -m squared, so -1 squared is 1. M squared, that's going to leave me with 1m squared, and we don't need to write that 1 at the beginning. So here I have -n to the 7th divided by -n in brackets cubed. Because there's no brackets, that means the 7 only applies to the n. So that's like -1 times n to the 7th divided by -1 cubed times n cubed. So that gives me -1 n to the 7th. And on the bottom, -1 cubed is still -1, and then I've got n cubed. Well, -1 divided by -1 cancels out, that's just 1. And n to the 7th divided by n cubed is n to the 7 minus 3, which is n to the 4th. All right, now taking a look at B, this is where things get a little bit trickier. First, I want to remind you about order of operations. So BEDMAS, brackets, exponents, dividing and multiplying, adding and subtracting. So when we're working through these, we want to simplify within the brackets if we can, then we'll deal with our exponents, then we'll deal with our multiplying. So if you notice here, we have nothing that needs to be simplified in the brackets, but I do have that exponent, so I need to bring that in first. So that's going to give me -2 in brackets cubed, x to the 6th, y to the 9th. And then we have 4x to the 5th, y to the 7th. So -2 cubed is -8, x to the 6th, y to the 9th. That's all simplified. And then 4x to the 5th, y to the 7th. Now I've taken care of the exponents, I'm moving on to multiplying. So I'm going to multiply my coefficients. -8 times 4 is -32. X to the 6th times x to the 5th is 11. So x to the 11, and then y to the 9 times y to the 7 is y to the 16. Again, I'm going to show you how to check this with your calculator. So for this example, I'm going to choose to make x 2, so 2 store x, and then 3 store alpha y. So the first example, -2 x squared alpha y cubed, and then to the exponent 3, and then we have 4 x to the 5th y to the 7th. And if I've simplified correctly, I should get the same answer. So -32 x to the exponent 11 times y to the exponent 16. Now, this is expressing my answer in scientific notation, so that means -2.82 times 10 to the 12. That e means times 10 to. It really doesn't matter right now about that that piece just recognizing that these two are the same answer. Therefore, I know that I've simplified this correctly. So as we move through these examples, you're going to notice that they're getting more and more complex. Again, we want to remember those basics. We want to remember our exponent laws, and we want to remember order of operations. So for this first example here, I've got 4b cubed times 3a to the 6th, all divided by 6a to the 5th, and then put to the exponent of 4. So I do have two options here. I can bring in that exponent right away because everything's being multiplied within the brackets, or I can simplify my brackets first. So I'm going to show you both examples. Let's start by simplifying in the brackets first. So 4 times 3 is 12. And then we have a to the 6th and b cubed. So typically we're going to write these in algebraic order, which is alphabetic order. And then we have 6a to the 5th, and all of that is being put to the exponent of 4. Now we can simplify further. 12 divided by 6 is 2. a to the 6th divided by a to the 5th is a to the 1, and b cubed. Now you don't have to write the 1 there, but I find it's helpful, especially when we're bringing in exponents. Now our last step is to bring in that exponent. So remember, this is 2 to the 1. So 2 to the 1 raised to the 4th power is 2 to the 4. Then we have a to the 4 and b to the 12. And our final step is just to simplify. So 2 to the 4th is 16. We're going to have 16 a to the 4th, b to the 12. Now the alternative method for this is to maybe simplify a little bit within the brackets and then bring the 4 in. So we're going to have, again, 4 times 3 is 12. We've got a to the 6th, b cubed, all divided by 6a to the 5th. And at this point, you might choose to bring in the 4. So 12 to the 4th becomes 20,736. And then we have a to the 24 and b to the 12. On the bottom, 6 to the 4th is 1,296. And we have a to the 20. When we divide those two coefficients, we're going to have 16. a to the 24 over a to the 20th is a to the 4th, and then we have b to the 12th. So you'll notice that these give me the same answers, but I just got there in a different way. So as long as you're following the rules of math, you're following order of operations, you're following your exponent laws, there's more than one way to get to that answer. So in our next example, we have 16 times bracket m cubed n to the 5th and then squared. It's important to pay attention to what that squared applies to. Notice here the 2 applies to the 5, the 2 applies to the 3. There's a bracket so the 2 doesn't go any further. So I think about this like a stop sign. The first bracket says, come on in. And the last bracket says, stop, don't go any further. So here I'm going to have 16 times m to the 6th times n to the 10th. And on the bottom, this 3 is going to come in. Remember, 2 cubed. So 2 cubed times m to the 6th. And now I'm just going to be simplifying. So on the top, everything's simplified already. So 16m to the 6th, n to the 10. On the bottom, 2 cubed is 8. We've got 8m to the 6th. Now, dividing our coefficients, 16 divided by 8 is 2. M to the 6th divided by m to the 6th is going to cancel out, and I'm going to be left with n to the 10. Now, when I say cancel out, that means that they're dividing to be 1. So my final expression is 2 times n to the 10th. So as we look at this example, what we want to do is pay attention to where our brackets are and what our exponents are applying to. So we have 72, a to the 4th, b to the 10, and then our 4 applies to the -1 and to the c squared. So that's going to be -1 to the 4th, again, brackets are important, and c to the 8. In the denominator, we have 6, and then we've got those brackets. So 2 cubed, and if you know 2 cubed is 8, we can write that. We've got 2 cubed is 8, and then a cubed and b to the 6th. Then we have c to the 8 and b cubed. Now, because we've distributed that 3 through the brackets, we really don't need those brackets anymore, but I've still left it in brackets there. We're ultimately just multiplying, so we're just going to combine all of our terms that we can combine. So on the top here, we have 72 times -1 to the 4th. Well, -1 to the 4th is a positive 1. So we're going to have 72 a to the 4th, b to the 10, and c to the 8th. In the denominator, we've got 6 times 8, which is 48. We've got a cubed, b to the 9th, because 6 plus 3 is 9, and then c to the 8th. And now we just need to simplify. So 72 divided by 48 can reduce to 3 over 2. So we're dividing each of them by 24. So we've got 3 over 2. A to the 4th over a cubed becomes a to the 1. b to the 10th divided by b to the 9 becomes b to the 1, and then c to the 8 over c to the 8 becomes c to the 0, which is 1. So we can write c to the 0, but we don't need to. So our final answer can be written as 3 over 2 ab, or we can write it as 3ab all divided by 2. So let's take a look at h. For this example, again, we want to simplify within the brackets first and then bring in our exponent. So negative 16 times 2 is negative 32. X to the 5th times x squared is x to the 7th. And y cubed times y to the 6th is y to the 9th. And in the denominator, we have 8x y to the 7th. And all of this is in brackets with an exponent of 3. Negative 32 divided by 8 is negative 4. X to the 7th over x to the 1 is x to the 6th. And then we have y squared, all to the exponent of 3. When we bring in that exponent, we've got negative 4 in brackets cubed, x to the 18, and y to the 6th. So negative 4 cubed is negative 64, x to the 18th, and then y to the 6th. And again, remember that all of these can be checked with your calculator just using substitution. Now we're going to take a look at one final example, which is actually an extension. It goes beyond what we would typically be doing in grade 10, but I just want to show you that you can apply these exponent laws at a higher level and still get the same answer. It doesn't matter whether your exponent is a number, a natural number, a whole number, an integer, or whether they're variable expressions. We can still follow those same rules. So here I've got b to the 4x plus y divided by b to the x minus 2y. We have two powers, we're dividing them and they both have the same base, so that just means we can subtract our exponents. So this is going to give us b to the exponent 4x plus y minus, and again brackets are important, x minus 2y. So that gives us b to the 4x minus x, which is 3x, and y minus negative 2y, so y plus 2y, which is 3y. So that expression can be simplified to be b to the exponent 3x plus 3y. So when it comes to combining exponent laws, our examples can get quite complex quite fast. So it's really important that you do lots of practice and check for those silly errors. It's going to happen so often that we go 2 times 3 and we write 5, we add instead of we multiply. We mean to write a 7, we write a 4. So it's really important that you just check for silly mistakes and take advantage of the opportunity to check your work using substitution. All right, guys, that's all for today. Have a great day and I'll see you next time.